Hello students, welcome back in today's session. I hope my voice is clear to all. So in today's session, we are going to focus on some functions. Okay. So mainly we are covering NCERT section 2.4.1. So before going to the theory, there's a small disclaimer. The images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at SATHEE@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Thank you. So in today's session, we will be seeing about a real valued function. Then we will be covering some standard functions which are very important, such as identity function, constant function, polynomial function, rational function, modulus function, signum function, and greatest integer function. We will be seeing their definitions, their domain, codomain, range, as well as their graphs. Clear? So, first, real valued functions. What are they? Quite simple. That if you are given with a function which has either R, the whole real number, or one of its subset as its range, then we will call such functions a real valued function. Clear? Suppose if your domain is also from real numbers, then such functions will be a real function. Clear? So real valued function, we are only focusing on range. The range must be from reals. But in real valued function, we want both range as well as domain from the reals. Clear? Quite simple definition. Now, this example. So, n represents your set of naturals, this capital N. And we are having a real valued function. A real valued function. F from where to where? N to N. From where? From N to N. And defined by 2x plus 1. Clear? Now, using the previous definition, what we have to do? So simply, first of all, this is your real valued function. Why? Because both domain as well as range is a subset of reals. Clear? So this given function is your real valued function. Now, using this relation, this definition, what you have to do is simply complete the following table. What table? This table. That suppose x is 1, then find out f of 1. If x is 2, then find out f of 2. If x is 3, then find out f of 3. Clear? And so on. So solution, quite simple. That the completed table is given by this, that f of 1 is going to be 3. Why? You just have to substitute 1 over here. So 2 times 1 plus 1 is what? 3. So now in this we are going to associate 2 with 5. Why? Because if you substitute 2 Here you will get what? 2 times 2, 4 plus 1, 5 and so on. Clear? Now, identity function. Suppose R, which is a set of real numbers, then define real valued function f from R to R. If you are having any function f, then this set is nothing but your domain set and this set is nothing but your codomain set. Clear? And defined by simply fx is equals to x. Meaning what? Whatever the input, the output will be the same. So this identity function is nothing but a machine which gives me the same output as my input. If you give 2 as its input, then output will be the same. Clear? So in general, if input is x, then output will be the same as x. Clear? So here, domain and range of f is complete set of reals, and if you try to draw its graph, then the graph will be like this, which passes through the origin 0, 0. How we got this as our graph? Quite simple. So just observe some input and outputs. If you give input at 0, what will be its output? 0. So meaning 0, 0. So 0, 0 point will be here in this Cartesian plane. Yes. Now for other, if you give input as 1, then output will be also the same 1 by this definition. So for input 1, the output will also going to be 1. So 1, 1 pair. Now for 2, 2, 2. Yes. So 2, 2 ordered pair will be here. 4, 4 ordered pair will be here. Clear? Now what you have to do in order to get the complete graph, you just join all the points. You will get this line which passes through the origin as your graph for the identity function. Is it clear? Now, constant function. So, function f defined from R to R. This R is its domain. This R is its codomain. Clear? Defined by that y, which is fx. Fx is equals to some constant c, where x belongs to the set of reals and c is some constant. Clear? So simply what you have to do is, so how my x and y related? Quite simple, that whatever the input, the output will always be the constant c. Clear? So here domain is the complete set of real R, but in this case the range of this function, constant function, is going to be what? This singleton set C, because every element of my domain is only associated to the single element, which is C, some constant. So my graph for such type of functions, constant function, will look like any line which is parallel to x-axis. If you take C as 3, meaning fx is equals to 3, this is your constant function, then the graph will be parallel to x-axis. You can see. Okay, quite simple. Now comes to this polynomial function. A function f from R to R is said to be a polynomial function if for each x in the set of reals your function is defined in this manner that y is equals to, or fx is equals to nothing but a naught plus a1x plus a2x square till an x raised to power n, where n must be your non-negative integer. And what? N must be your non-negative integer. And a0, a1, a2, the coefficients of x must be from the set of reals. So if you are having such type of or such form function, if you are having any function of this form, those function will be your what? Polynomial functions. Clear? Now let's see an example. So if fx is written like this, that x cube minus x square plus 2, and gx like x raised to power 4 plus root 2 times x, and these two given functions fx and gx both are examples of polynomial functions. Yes. Why? Because they are of the form a0 plus a1x plus a2x square till an x raised to power n. If you see this function hx, which is defined by x raised to power 2 by 3 plus 2x, this is your not a polynomial function. Why? Because in this case we are having x raised to the power 2 by 3, which is not a non-negative integer. If you recall the definition, if you recall the form, we want the exponent of x must be non-negative integers. Clear? So hx is not a polynomial function. So quite simple, that x raised to power 2 by 3 has an exponent of 2 by 3, and 2 by 3 is not a non-negative integer. It is a fraction, a rational one, but not an integer. Clear? Moving to next. Now this example. Suppose f from R to R defined by fx is equals to x square, where x belongs to the set of all reals, meaning input coming from where? The set of all real numbers. Then complete the table given below by using this definition. So what definition? This definition given to us, that, and then answer that what is the domain, what is the range of the given function, and also draw the graph. So table is given to us, quite simple, that we are given with x, some values for x, minus 4, minus 3, minus 2 and till 4, and we have to find the corresponding y value according to the rule defined here. Clear? Quite simple. So solution. So the completed table is this. So if you give input minus 4, then your output will be what? Square of the number, square of the input. So minus 4 times minus 4 is plus 16. Now minus 3 square is 9, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9 and 4 square is 16. Clear that how we are getting this table. Now the domain is simply the set of all reals. So domain is simply the set of all reals. Now what about the range? Quite simple, the range will be your collection of all x squares such that x belongs to set of all reals. Clear? Now the graph is simply of the form parabola. So, or you can say the open cup. Clear? Now this example. So a function given to you from R to R, meaning your domain set is the complete set of R and the codomain set is also the complete set of R. The function defined by x cube, meaning the x is related to the element x cube. Clear? Then what you have to do is simply draw the graph for this function fx is equals to x cube. Quite simple. So we are going to first of all find out some ordinate pairs. So, or just elements are associated to what element. So 0 is associated to 0, 1 is associated to 1, -1 is associated to -1, 2 is associated to 8, -2 is associated to -8, 3 is associated to 27, and -3 is associated to -27. And these points are enough to plot my rough diagram. Clear? So the simply this function, which is your relation, yes, a special type of relation. So collection of all ordered pairs x comma x cube such that x must be from reals. So simply just 0 comma 0. So just put 0 comma 0. So 0 comma 0 will be here. For 1 comma 1, or you just try to see that 2 comma 8. So 2 is here. Now what about 8? 8 will be here. So 2 comma 8 point. Yes, 2 comma 8. Now -2 comma 8. So -2 is here and 8 is here. So -2 comma 8 will be somewhere here. Yes, now just join them. Clear? So joining. So if you try to put more points, the graph will be more accurate. Clear? So if we have more points, then the graph will be the more accurate. So if you put a -2 now for 1 to 1, so 1, so just assume that we are having 1 comma 1 somewhere here and -1 comma -1 somewhere here. Yes, so my graph will look like this as shown here. Is it clear how we are getting my x cube graph? Now rational function. So a function of the type fx by gx, where fx and gx both must be polynomial functions, where the gx cannot be 0 in its domain. Clear? So any function of this type satisfying that both the numerator function and the denominator function must be polynomial functions, provided the denominator cannot be 0 in its domain, then such type of function will be your rational functions. Clear? Let's see it by an example. So suppose you are having f from so in this case domain is your all real number except 0 and codomain is your complete set R. So defined by fx is equals to 1 by x. So fx is equals to 1 by x. X coming from its domain. Domain is all real number except 0. So x can be any real number but not 0. We cannot take 0. Now what you have to do is quite simple, that first of all complete the given table. So this table you have to complete it. Then answer the domain range of this function. What will be its domain and its range? Quite simple. So solution. So the completed table is, so we are given with input values. So we just have to find out the output values according to this rule, this relation. So if input is -2, the output is going to be 1 by -2, which is -0.5. if input is minus 1.5, then the output will be 1 by minus 1.5, which is minus 0.67. If input is minus 1, then the output will be 1 by minus 1, which is minus 1. And same goes for the other values. So for minus 0.5, the output will be minus 2. For 0.25, the output will be 4, and so on. Quite clear that how we are getting our outputs. Now, in order to answer the domain is quite clear, that the all input values. So we can give what values as my input? All real number except 0. I cannot give 0 as my input value, because if you get 0 as input, then what will be your output? 1 by 0, which is not defined. Yes? Clear? So all real number except 0 will be my domain set. Now what about range set? Range set is also your set of all real number except 0, the same as the domain. Clear? Now what about its graph? Quite simple. We have already seen input and outputs, meaning we can easily put our coordinate points on the Cartesian plane in order to get the graph. So by just putting these points, you will get the idea that how my graph will look like. So your actual graph will look like this. Clear? So for minus 1, or you can see for 1 comma 1, you will see your point will be somewhere here for 1 comma 1. Okay. For 2 comma 1, the output is going to be 0.5. So as you can see, for 2 comma 1, the output will be somewhere here, which is might be 0.5. Clear? Now, modulus function. If function f from R to R is defined by fx is equals to mod x. So how we read this? Mod x simply, or absolute of x. What this represent? Quite simple, that for every non-negative value of x, the function fx is equals to x. So if your input is non-negative, meaning 0, 1, 0.1, 0.2, 0.3, 1 upon 100, any non-negative real number, then output will be the same as my input. If you are giving input as negative number, real number, then output will be negative of that negative number. Clear? So quite in mathematical form, the mathematical form will look like this. So if input is x and your x is non-negative, meaning it could be 0 or greater than 0, then output will be the same as the input. But if your input is negative, any negative real number, so this represents what? Negative real number. X is less than 0, meaning any negative real number. If input is any negative real number, then output will be minus of that negative number. Clear? If you observe some examples, it will be all clear. So what about f of 1? 1 is what? Your positive real number. So output is 1. F of minus 1. Minus 1 is negative, meaning output will be minus of the negative number, which is minus of minus 1, which is 1. Clear? Now, the graph for this modulus function will look like this. V type. Vertex at 0, 0. Clear? Now, signum function. How we define our signum function? Quite simple. If f from R to R is called the signum function, if for any input positive input, if you are getting the output 1, for input 0, output is 0. If for any input negative, for any negative input, the output is -1. So if you are having any function of this form, this type, that function will be your signum function. Clear? How we defined our signum function? Quite simple. Any function of this specific form. Now the domain, quite simple. The domain is all real numbers. So domain is simply collection of all inputs. So you are giving all real numbers as input. Here you are giving all positive, here you are giving all negative, and here you are giving 0. So this combines, gives me all real numbers. So domain is complete set of reals. What about range? Range is nothing but, in function, range is collection of all outputs. So you are just getting 3 outputs, 1, 0, -1. So range set is simply collection of all 3 elements, -1, 0, 1. Clear? Now comes to the graph. So graph will be quite simple, of this type. For any positive real number, the output is going to be 1. So suppose for 1 the output is 1, for 2 the output is also 1, for 3 the output is 1. So join them, you will get your one ray which is extending towards plus infinity. Yes, and for negative real numbers you are getting another ray which is extending towards the minus infinity and parallel to x-axis. Both rays are parallel to x-axis. Clear? Now for 0 we are getting 0. So for 0, 0. So if you are drawing this graph for signum function, you have to explicitly show by just making bold point to the origin that this also in our graph. What this shows, that 0, 0 also in the function. Clear? Now greatest integer function, quite important. F from R to R, meaning real numbers to real number, defined by fx is equals to, notation is simply box x. So how we read it? Quite simple, greatest of x, greatest integer x. What it represents? Quite simple, it gives me the output, assumes the value of the greatest integer less than or equal to x. Clear? If not, just be with me, it will be all clear by if you see an example. So such type of functions will be your greatest integer function. So for example, so if you give input in between this specific interval, clear, if you give input as say -0.5, so according to the definition, its output will be a value which is greatest integer. So your output, so by definition your output must be integer. Clear? So greatest integer less than or equal to x. So if your input is -0.5, so first of all list all the integers which are less than or equal to x. So first of all list all the integers which are less than or equal to x. Clear? And then among them you have to find the greatest integer. So the greatest integer will be what? Your -1 in that specific case. So you can do the same thing in this for any real number in this interval. Clear? So if you pick any real number in this interval, if you pick 0, if you pick 0.1, if you pick 0.2, if you pick 0.0009, if you pick a 2 by 100, so all these numbers belongs to this interval. Clear? Then the output will be 0. The same goes for the greatest. So if you pick any real number in this specific interval, the output is 1. In this interval 2 less than equals to x less than 3, the output is going to be 2. The graph will be like this. By just as you are seeing that what we are getting is quite simple, that in this specific intervals we are getting an output. Clear? So for values 1 to 2, meaning in this interval the output is going to be simply 1. So we are having, as you can see, output is 1. Clear? So thank you all. We have to end our session here.